zeros of polynomial functions, so we'll find the x values that cause this function to be equal to 0. So we set the function equal to 0, and remember, when we have a polynomial that's already in factored form, we can use the zero product property to solve. So the zero product property says once I have products, factors that are multiplied together, I can set those factors equal to 0 and find the zeros of the polynomial. So I have 1 at 0, I have 1 at -2, and I have 1 at 1. So I put a 0 down, I put an x-intercept at -2 and at 1. All right, so I know the degree of this polynomial. If I multiply all of these x's together, I get x to the third. So that's my degree. And since the numbers in front of x are all +1, my leading coefficient is positive. So I know that my graph acts like a line at its end behavior. So this will start low and finish high. Okay, so let's talk about multiplicities. So all of these zeros had multiplicities of 1. That means the exponents of the factors were 1, so they only appear once. All right, so let's look at a different one. Let's do minus. Okay, so I'm going to set these factors equal to 0. By the way, to get it in factored form, we'll have to factor. So it is squared, but what happens when I take the square root of 0? I take the square root of both sides, I just get 0. So the squared just means that I have 2 of those factors multiplied together. So you don't have to write them both twice. We don't have to use the exponent. You can just write the plain factor. All right, so I set that one equal to 0 and solve, and I get x equals -1. I'm going to write m2 underneath, which means multiplicity of 2. X minus 2 equals 0, so x equals 2, multiplicity of 3. And x minus 4 equals 0, which means x equals 4, multiplicity is 1. And I'm going to sketch my graph. So I have a 0 at -1. I have a 0 at 2, and I have a 0 at 4. Now you can plug in other points, other x values to find other points. Like I could plug in 0 to find my y-intercept. So when I plug in 0 for x, if you think about that, I plug in 0 here, here, and here. I have 0 plus 1 squared, x minus 2, or 0 minus 2 cubed, and 0 minus 4. So that leaves me 1 squared, -2 cubed, and -4. So that's 1, -2 to the third is -8. -4, so +32. All right, so this is 32. We're counting by 4s, we'll say. So this is 0, 32. So that's going to be way up there on my graph. This is -1, 2, and 4. Okay, so what do these multiplicities mean on the graph? The 2 means we're going to bounce on the graph. Even numbers means that there's a bounce, so it's going to change from decreasing to increasing or increasing to decreasing. Multiplicities of 3 or 1 or odd numbers means they will cross the x-axis, and the higher the number, the more it flattens out when it crosses. So it'll appear like it's wiggling through. All right, so at -1, I have a bounce. First of all, we need to also look at end behavior. Let's look at the degree. So 2, 3, 1. When I add those powers together, my degree is 6. My leading coefficient, 1, 1, 1. So my leading coefficient is positive. So that means my end behavior looks like that. So we'll start high, and we're going to bounce at -1. So let's do that first. So we're going to start high and bounce at -1. Then we're going to come up to this y-intercept. And then at 2, we're going to wiggle through. And then at 4, we're going to cross through. Yeah, my wiggle doesn't look that great. There we go. Okay. So you can see the difference between this one and this one. Across just goes straight through. Wiggle kind of flattens out and then goes through. So we can go the other way. I can give you a graph and ask you how many, or what the degree is, what you think the possible degree would be, and then what type of factors, x-intercepts it has. See if you can write the equation. So let's try one. Okay, so we know the degree is even, and my leading coefficient is positive. Sorry, leading coefficient is negative because they're both opening down. All right, so we know that. We know we have an x-intercept at -3, at 0, and at +3. I have a bounce, so this is multiplicity of at least 2, could be 4, but that's the lowest. This one, multiplicity of 3, could be 5 or 7, but that's the lowest it could be. And then this one cuts straight through, so it has multiplicity of 1. So when I write these, I have x equals -3, multiplicity of 1, x equals 2, x equals 0, multiplicity of 2, x equals 3, multiplicity of 3. All right, these are my x-intercepts when I put them into factors. So I'm working this backwards now. So we're going, like on this one we did before, we're going from the x-intercept back to the factor. So I just move the 3 over and set it equal to 0. So this would be x plus 3 equals 0. X, there's plus 0, you don't need to write that. And then x minus 3 equals 0. Okay. Now we need to talk about these multiplicities. So I'm going to go ahead and write f of x equals, I have x plus 3 multiplicity of 1, x multiplicity of 2, and x minus 3 multiplicity of 3. So that's what it would look like before I multiply it out. And you can rearrange if you want to. We usually put the x in the front, so it looks like x squared times x plus 3 times x minus 3 cubed. So that would be what it looks like before I multiply the whole thing out. Okay, so we should be able to recognize how to write factors. We could also have some complex numbers where, we get imaginary numbers when we find the zeros, and we will talk about that when I see you again. But the last thing I want you to think about and have this ready when we talk is on this graph, where is my function positive and where is my function negative? So what are my intervals where my function is positive and negative? All right, so have that ready to go when I see you again. Bye, guys.